Thank you for joining my talk called Innovation Without Asking Permission, because generally who likes asking permission? The talk is about the use of new technology and the fear of change in existing applications. I'll start with a very, very brief introduction about myself. My name is Bart Blommaerts. I am a hands-on application architect. I live and work in Belgium. And at the beginning of this year, I started my own company called BB Consulting. I'm currently working for a large bank in Belgium in the cloud native area. If you want to contact me, if you have any questions, remarks, or just some random rants, you can always reach me via my Twitter handle. So, enough of the introduction. Let's get started. Software development is awesome. Who agrees with me? All of you do. Okay, that's great. That's the right answer. It's just like the sports car. So when you're passionate about software development, and I think most of you will be, you're aware that there's a constant change in our landscape, in the software landscape. A long time ago, we were doing server-side rendering, and then we decided, no, let's do client-side rendering. Nowadays, everybody's thinking, no, let's do server-side rendering on the client, micro front-ends and things like that. In the beginning, we had large monolithic applications on enterprise application servers. Then we thought, no, let's go to microservices. And nowadays, we're thinking, okay, maybe we need to go serverless. So there's this constant evolution. And if you're a passionate software developer, you will keep up to date with this. You will go to news sites, you will follow people on Twitter, you will go to conferences like this one, because you want to learn about it, you want to stay in touch with our ecosystem. And every conference really introduces new technology and practices that are really interesting. All of the buzzwords on this slide are actually topics from this conference, so you can learn about blockchain, deep learning, serverless, etc. at this very conference. It's really a great industry to be part of. It never gets boring. But then you go home and you start looking at your project that you're doing right now. Maybe for the record's sake, who here is working on an application that started like over a year ago? Keep your hands up, over 2 years ago? So the same people apparently. Over 5 years ago? Somebody is laughing. Over 10 years ago? Really? Okay, even 15? Okay, so 10 years ago, great. But that's not a bad thing. I mean, most developers, they are working on existing systems. Often these are called legacy systems, legacy applications, and that's not a bad thing. Actually, it's a very good thing. Because if an application becomes old enough to become legacy, it has proven its point. It has a value. People are using it. If you're creating a greenfield application, you don't know yet if they're going to be users of your application. So, as I said, many people are working with some kind of legacy code base, and I know that you're interested in all of the previous buzzwords that we were looking at. You want to do serverless, you want to do microservices, but it's very difficult to do that in a legacy code base because it's possible that everything you touch makes the entire application explode. Who has witnessed that by touching something small, the application stopped behaving normally? Half of you is lying. Everybody saw that, I'm sure. You can do pet projects, you can side projects, and I recommend doing that. It's really fun. You can experiment with things, and it never gets finished, but that's part of the fun. But wouldn't it be really cool if we could do some of the interesting new innovative technology on our legacy applications? So that's what this talk is about. And I'd like to share a quote that I recently read on Twitter saying that there's a colossal gap between the solutions presented at conferences and the kinds of problems that many folks are actually trying to solve. You just proved that by raising your hands. But that's okay. I mean, conferences are here to inspire, to make sure that there are certain aspirations of developers that we're passionate about what we're doing. But maybe there's a way to bridge that gap. So the first thing that you want to investigate when you're working on a legacy monolith application is service decomposition. Now, word of warning, this is not an introduction on microservices. There's plenty of talks that do that. We are going to use microservices as a means to an end, a means to be able to use innovative and new technology, a means to explore new fields for our legacy application. So it's not only about the fun stuff, it's not only about using the latest alpha version of something, it's about the hard stuff as well. So embrace yourself for this. Service decomposition means splitting up the application, the legacy monolithic application, into several smaller parts. These smaller parts will be easier to test. Maybe you have scaling issues. Maybe you can introduce new technology there as well. Maybe you can start experimenting with new ways of solving problems. Now, in general, there's 3 ways of splitting up the application, of decomposing the monolith. It's about the splitting part, where you just take part of the application and you move it somewhere else. There's the strangle pattern, which means we are going to take part of the application and we're going to re-implement it, maybe using new technology. And then last, there's also the extend pattern, where you implement new features outside of the application to prevent the legacy application from growing. Let's quickly look into these into detail. So when you talk about splitting applications, you will notice that many legacy applications are organized as horizontal technical layers. There's a persistence layer, there's a model layer, there's a view layer, and you don't want to start decomposing based on those technology layers, because when you do that, every microservice will be calling every microservice. We're not interested in creating a persistent microservice that does all the database access, because when you're doing microservice, when you're doing these, for example, over HTTP, there will be just huge amount of unnecessary network traffic. When we are looking at microservices, we want to split up on vertical functional boundaries, and I will go into these a bit later. So functionality is really a differentiator, and it's going to become a lot more easy because all the information that's necessary for one functional boundary can be in that specific microservice, so the view layer, the persistence layer, etc., etc. So now, how do you do this? It's generally by focus on the data model. The data model will have a lot of interesting information to know which part of the application are being used, for example, by which views, which pages, which front ends. If you have a legacy application that has this vertical layering based on functionality, then you're in for a treat. Then splitting up the application will be fairly easy. Unfortunately, I have not seen that very often. Most of the time it's just the technical layering that was a best practice a long time ago. Strangling the application, it's a pattern made famous by Martin Fowler in 2004. It's 14 years ago, and it's still valid. It's still difficult. So the goal is to make the monolith smaller by extracting and re-implementing certain functionality. When parts of the application needs to be redesigned, when there's new features that need to be implemented, you can call this your domain of change, and that's the ideal starting point to start decomposing and the monolith using the strangler pattern. Personally, I think this is the more difficult way of decomposing your monolith application, so that's why during the demo this is also what we will be doing. You can use an anti-corruption layer for decoupling. I have a couple of slides to go into that into detail. Now, obviously, when you're re-implementing something, you need to make sure that the functionality is still correct. You will probably need to write more unit tests or integration tests in your legacy application as well. So there is an impact as well. And then extending is minimizing changes to the existing application and then implement a new feature as a microservice. This may sound fairly straightforward, but generally, the microservice that you're creating will also be needing information from the monolith application. And we don't want to have that tight coupling between those two, because if you have tight coupling between two applications and you're just calling them synchronously, just leave it as one modular monolithic application. Don't go into microservice, because it will make your life unnecessarily difficult. When done successfully, this will actually prevent the monolith from growing. And here we also need the anticorruption layer to make sure that domain entities from one application don't intermingle with the other one. Now, you don't need to stick to a single approach. There's multiple doors that you can open. In general, when you start really with an application, with decomposing your monolith application, pick one, start with one, but in general, you will probably all need all three patterns to do this. Now, the anti-corruption layer. So both in the strangler and the extend pattern, I mentioned these anti-corruption layers, but what is this? As the name implies, it's a technology layer, and it will make sure that applications can use the optimal domain model for their core business, for what they're specifically doing, for their boundaries. And you still will be able to interact with other domain models. So, for example, if your application needs to deal with a database, it can use a database where the domain model, the database model, is applicable for that microservice. It's not an undesirable or inapplicable state that's just huge, that covers all possible use cases of the application. So in the anti-corruption layer, you can do the mapping, the translation from one domain model to the other domain model and vice versa. It's a very nice way to minimize coupling and to enforce bounded context. Since you will be doing translation between models, you will need some kind of well-defined API to make sure that you're doing the mapping, the translation correctly, and maybe your new microservice can use the API instead of technical implementations, as we'll see in a bit. Now, an anti-corruption layer deals with data access, and there's three approaches that we can use. There's the shared repository, data synchronized repository, and event-driven synchronized. So let's look at this into detail. So imagine that you have a monolithic application on the right-hand side. For you guys, it's the left-hand side. And it's just using a database. Most information systems that we use have some kind of database. Now, the way that the monolith is layered, whether it's like on functionality or on technology, is not necessarily relevant for this thing that I'm trying to explain. But it's just one application consuming one database. Is anybody who hasn't seen an application that just uses everything straight in one database? So everybody has seen this is your legacy application 101. And you want to do innovation, you want to experiment. So you say, okay, we're going to create a new microservice, we're going to use new functionality, we're going to create something. But what we're creating actually will need information from that legacy database. It's using the same kind of data. So we're going to introduce an anti-corruption layer in between those. And the anti-corruption layer will do, as I said, the translation between your legacy application and your new microservices. What's very interesting, what I really recommend is that you provide a nice API so that the microservices can consume the API of the anti-corruption layer, because when you're doing it that way, your microservices will be able to use the API and the ACL will become your persistence layer. I think this is a very useful and helpful step in progress, but you can immediately see that we need to do more. With the shared repository, with the shared database, when the data model changes, then it potentially changes in multiple locations right now. Maybe you need to change your monolithic application. Likely you will need to change the ACL, and worst case you will also need to change the microservices. That's not something that we want. We need to do better. So the first thing that we can do is when we start introducing what's called polyglot persistence. So every microservice gets its own database. This is generally a best practice. I think that's common with microservices right now. It enables us to tailor the database to the microservice and to have a true polyglot persistence. We have true loose coupling between your different applications. So changes to the data model now have less impact on the microservice, and this anti-corruption layer can take care of the mapping. Ideally, the anti-corruption layer will populate the new databases asynchronously. So when something happens in your original legacy master database, those changes are persisted asynchronously to the database. But still, we can do more. I think what many people right now see as the most mature level of microservice is using events, is the event-driven approach. And in this event-driven approach, the producer of the events, so the monolith in this example, will put all the information that's useful for the outside world on a queue. So it's not reading this from the database directly, it's actually software components talking to the queue. And the ACL will be a consumer of that queue, and in turn it will publish new messages that can be consumed by your microservices. From a data point of view, it's important that it's the monolith that it's producing the events, but in time, why wouldn't it be possible to do it the other way around, that your new microservice also publishes data, publishes events that are useful for your monolithic application. Now it's easy to talk about events, but let's go into detail. What is this an event? In general, the first definition that everybody gives, well, an event is something that has happened in the past. It's, for example, calculation initiated. We have started something and somebody needs to react to that. But very important that an event can contain three kinds of data. There's the data that the event owns, so the data where the publishing service is master. It's data that the event needs, so the publishing service is not necessarily the master, but it knows that consumers will be interested to have that data as well. And then reference data, so just meta information, maybe enumerations. The example that I always give, if you're booking booking a holiday and you want to have the average temperature of whenever your booking is, you will need to pass that information along. It doesn't change. The average temperature for Riga will always be the same on the different months. So this is the 3 types of data that's very important to put in an event, and we will see during the demo why that's so important. So the event needs to carry all the data that's needed to process it. There should be no additional queries to the publishing system after the event has been published. This is typical in legacy applications because the data that you might need is only 1 query away, so developers will not think about making sure that the events are constructed properly. They just will say, okay, I'm just calling this calculation method, and when it needs information, just go fetch something from the database. And that's exactly what we are trying to prevent, because we are reintroducing coupling like this. Also important, events are generally immutable, and they represent business capabilities. So it's not just a representation of a table in the database. Is that clear so far? Okay, great. Bounded contexts. Bounded contexts depict the boundaries of typical microservices. It's a term that was made popular by domain-driven design, by the domain-driven design movement. I think it's very interesting, but there should be some warnings when you intend to do DDD. I have a couple of sources at the end of the presentation, and there's one talk by Greg Young about something that he called DDD Light. And I think it's a must-see for everybody who wants to do DDD, because he specifically mentions some anti-patterns and some reasons that domain-driven design projects often fail. I've seen most of these in practice, so Greg Young is the reference when it comes to these things. It's absolutely a must-see. It takes like 45 minutes. It's the most important 45 minutes of your life when you're trying to do DDD. Now, there's a lot of theoretical talk about domain-driven design and bounded context, but there's not often real-life cases. So I would like to do the opposite and start with a real-life case. It's based on a project that I did, well, it's loosely based on a project I did 2 years ago for the Belgian post offices. I won't go into details, but just some background information. In Belgium, by law, the mail delivery person is it's mandatory for him or her to pass by the houses of every Belgian citizen at least once a day. So that's a law. And as you can imagine, the things that are being delivered, and I'm particularly calling it things, they have evolved enormously. In the past it was letters, then there were newspapers. Now most of the time it's packages. It can be a lot of things. There's even countries in Scandinavia where you can have your mail delivery person do chores in your house, like maybe installing your decoder. That's something that's being done in Belgium as well. So they want to use the fact that the mail person passes by your house and do something useful with that. You can imagine that delivering a letter and delivering a package is done by different vehicles. So there's bikes, there's cars, there's motorcycles. Maybe one day they start doing electric skateboards, who knows. So everything is changing in that area. And some of these goods have time constraints. When you order fruits at Amazon, you want to have the fruits as soon as possible because you prefer to have fresh fruits. Well, I prefer to have fresh fruits. But it's also typical in Belgium that people can make specific demands to the postal services. So for example, if you have a large company and you get a lot of mail, you want to make sure that the mail is all combined in one large bag and it gets delivered to a specific person and he or she will figure out what to do with the mail. Also regarding time constraints, so maybe I want to have my mail before 9 o'clock in the morning or before 7 o'clock in the morning. Those kind of things are all possible right now. And what's really fun is these are being delivered to cities, to houses, and this change. Houses are built, sometimes houses go away, new streets are built. And in Belgium, because Belgium is Belgium, the postal office's geographical system and the actual real world geographical system, that's not the same thing. There's like this matrix in between that does, it's crazy, but some streets exist and don't exist at the same time. So you can imagine a lot of things are changing, and the use case, what we are trying to do is actually calculate the optimal delivery route for that mail person. We want to make sure that he or she loses as least time as possible. So one example that got me to think about this is, imagine that you have a municipality, but in the middle of the municipality there's a large river. and there are no bridges over the river. So if the mail person needs to do his municipality and needs to go all the way around the river, that will take a lot of time. It's probably more interesting to have the mail delivery person from the other side of the river also carry that part. So that's an actual problem of what they were dealing with. Our goal is to figure out where the microservices that we're going to do, so the calculation microservice, where it begins and where it ends. And we need to retrieve this information from the legacy monolithic application. And the legacy monolithic application has changed over time continuously. It probably started out as a very nice application at a given moment, but the people who started working on that in a nice modularized manner, they're long gone. They're not on the project anymore. So for this, we need to focus on business capability. What do we want to do, and not on the technology layer? So focusing on business capability means that we need a deep understanding of our business, of our monolithic application, and even more about what the future is of the business. What way do they want to evolve? So we need an obsession with business, and that's necessary to make this innovation relevant. When we look at the bounded context, we always start with the domain, and the domain in this case is mail delivery. Now, general tip, something that also, for example, Simon Brown often says, don't start with very small subdomains from the start. You can always reiterate on it further. You can always make it smaller if it's useful, if it's necessary. And every domain has subdomains, and these subdomains, they map with bounded context. So an application can have many subdomains, and right now we're looking at the optimal route calculation. But an application will also generally will have multiple domains, like for example the payment model or the user model. That's things that we're not talking about right now. Very interesting is an easy way to recognize these subdomains is again looking at your data model. A well-designed application, maybe it uses different databases for your different bounded contexts already, or different database schemas, and same thing goes exponentially for the domains. It would be very interesting to have a very well-defined application that uses a different database schema for payments or for mail delivery, for example. Now these are also tips that you can use in greenfield development. Data model design is something that's not to be left to coincidence. A lot of time when I hear people talk about polyglot persistence, they think, oh, it's going to be a very small database and we all don't really care about it and just figure it out and generate some tables from it. That's a very bad practice. I think those kind of skills have become even more important when you truly want to create a microservice infrastructure that can evolve over time. Now it's easy for me to give some examples on what these look like, but I also would like to give some tips on how you can actually determine these bounded contexts. So there's 3 tips. I already mentioned customer obsession, so you should talk to your business stakeholders. In general, preferably, they should know their business. I mean, that's what they're there for. What works well is creating a formal list of each potential subdomain and then write some kind of description for that subdomain. Why is it there? What does it do? What does delivery calculation do? Why do we want to have that kind of component? Making this list explicit will always yield new insights. It will even enforce your business to think about its business and mapping this with your IT. This is also how you, for example, define a ubiquitous language between all interested parties. And this list can also be part of your deliverable. So if you're creating a new microservice, maybe you can use the code to have that documented in your APIs. If you use Swagger or Spring REST docs or things like that, you have the possibility to just write extra text in there and make sure that you keep this documented very nicely. You can even go further. You can look at the different use cases that you have for a specific bounded context and also write these down. This can facilitate the communication with your stakeholders, but in general, if you have some experience in doing this, I recommend that you only make the use case list when you're doing the actual implementation and that you try to have your business stakeholders part of the implementation phase. That doesn't mean that they should be writing code, although that's really cool, but make sure that they know what they're paying you for actually. If your business stakeholder is, I'm not going to say an idiot, I was going to say something else, but if they can't help you, look at the data. I've mentioned the data a couple of times before. Ideally, your legacy system has a very nice document, up-to-date data model. that's also not very often the case, then you will likely need to re-engineer the data model or your persistence layer, and you can use that information as well to start with the data model of your new microservice. Looking closely at the data is probably one of the best ways to decompose a monolithic application, besides talking to your business stakeholders. Now, when there are no domain experts available, when the data model is incomprehensible, you can also look at the codes, and this not at the code base at a certain moment in time, but also at the evolution of the code base. For example, look at which files often are committed to your version control system at the same time. There are some tools that you can use, just some scripts that read from this revision history, and that you can get, okay, these files are always committed together, they probably belong together in some way. When we have identified these bounded contexts, we're also going to be integrating these with each other. So there's a lot of integration patterns that we can use. This is not a very popular topic, which is kind of strange, because when we're doing microservices, when we're doing distributed systems, it is incredibly important to look at these integration patterns. I'm not going into these into detail, but I really recommend reading, for example, the enterprise integration patterns by Gregor Hope. I personally think it's a super interesting part of our industry, but a lot of people are reluctant to investigate that. So if you want to do technical innovation in a legacy application, then it's probably a good idea to start investigating integration patterns. So what we are going to do in the demo right now is we will determine the bounded context for our application, and we were looking for a way to integrate it with a monolithic application via events. This new microservice that we're going to create will be a very suitable candidate to use new technology, to use innovating technology, maybe experiment with it. Yeah. So as I said earlier, important disclaimer, if you start with one microservices from one monolithic application, generally there will be more specific domains in your monolithic application. And what I find interesting, if you also combine the different microservices to that specific domain, then you can have a very nice map of your entire ecosystem. You can use a context map to see what influences what, and this will prevent you from like writing the same code twice or getting lost in distributed systems. Demo. Okay, so just for starters, I'm going to start a RabbitMQ. Oh, you can see that. Why can't you see that? There we are. So just random RabbitMQ, just download it, doesn't do anything else. And we're going to look at the legacy application first. So this isn't a fully fledged application, it's just to demo what I've been talking about. Okay. Excuse me? Yes. It's still resolving dependencies. Come on, work with me. Okay. So, we don't need this. When you look at a calculation algorithm, in most applications it will look something like this. So there's a method that's called calculate, and it receives some random information, we don't care about that. And then we're going to see that, well, this calculation needs to be initialized because I don't know what init methods generally do, they should not be there, BF constructors use those. And you see, okay, the information that we're passing to this method is not enough. We need to retrieve calculation info from somewhere. So we're going to query our database to get more information. The method in itself doesn't have what it takes to do the actual calculation. So when I was talking about passing events, these events should carry the information that's needed to do the calculation in this part. Then we're going to do random calculations, and then we're going to persist these. Again, we're going back to the data model. We're going to be coupled with it for some reason, and then when that's done, we're going to update the events to the method that we passed. So we're going to, if this were an event, we're going to try to change the immutable event that doesn't work either. And then we're going to need more calculation info because it's so easy to query the database. Why would we think about what we're doing? And then finally, there's the calculation. So I'm not going into the calculation because that's not specifically what I want to talk about, but I'll show you quickly. I'll switch back. Oh, that's not what I want to show you. Well, just not yet. It's good that I'm not in presentation mode, and you can see it anyway. So there's an event. Why am I specifically showing this? Because it's very important that you take care of the properties of the event. This is not a representation of a database table. This is a class that is only contains data that cannot be changed. We're deep copying it in the constructor, and we're just giving it a map, some kind of map. It can be a hash map, it can be whatever map, where we store the keys and strings, and then we just have objects for the data. So all data that is relevant can be put in that map. Now we're going to be publishing events like this to the queue, and for this I'm using Apache Avro. Because we need some kind of representation, and in general it's better to put serialized artifacts in this queue. And this is just what it's going to look like. So we're creating an Avro event. It's a representation of the class you saw earlier with a data map and a string, and with a Avro event. With a Maven plugin, you can generate just this code from it, and you can use these kind of messages to store to your queue. We'll have a quick look. This is the legacy application. So, So regarding the Avro configuration, this is how it's done. Just quickly show it. It's very easy. We have some schema message converter, and we're saying, okay, we have events of this type, the Avro message that I was set, and this we're going to use, and Spring knows what it needs to do with that. It's a Spring Boot application. And then we're going to look at the calculator itself. Oops, this is not what I want to do. Calculator. So that's not a very useful class now, is it? So I've shown you the event. The actual event, so the thing that we're implementing is just something that extends it, doesn't do anything else. And we're going to be producing events. So it's very simple. The Avro event I was showing earlier is the kind of message that we will be publishing. And in this method, you see, we're just going to build an Avro event and store it to the queue. I'll have a test that does that, if I remember what it's called. Something with test in the name. There we go. So there's a method called publish method that's just going to publish an event. And if we look at it, it's just going to hard code some data in it, just whatever data that's needed for the event. And we'll quickly run this. So in the first phase, we had one monolithic application that does the calculation. We have removed that calculation, and we're just going to put a calculation initiated event out. And we're going to, presentation mode is difficult. We're going to look at the consuming application, and the consuming application is right over here, and it doesn't really do a lot. I'll start it up in the meantime. The only thing that it's going to do is it also has the Avro configuration to know that it's going to use the Avro message converter to read the actual message. And then we just have the consumer that's going to print some information about it. And here you can see that the information has been printed, and then you can use that information to do your calculation logic. Just very quickly to show you that I'm not making this up. I'll change it to weekly, and I'll run the test again, and it will start Spring Boot. It takes a while. And then we should see the weekly message in just a bit over here. So we have created an event. Here it is, weekly. an event, it's being published from one service to another service via that RabbitMQ, and you can use the event, and you need to make sure that all the information that's needed is in there. Very short demo. So if you look back at the quote that I started the talk with, the problem we're trying to solve is calculating the optimal routes, and we have extracted that from the monolithic application. And in this new microservice, we can introduce new technology, maybe something that's very suitable to do the calculation. And maybe we need some different kind of scaling possibilities, maybe we want to run it on different systems, etc. And those options are available to you right now. Now, when you're moving functionality from one application to multiple microservices, you're going to introduce a lot of communication, the integration patterns that I was talking about earlier, and I used Avro in this. Now, it's very important that you establish some kind of API guidelines for your communication, because if your publishing and your consuming side don't know which kind of APIs they need to work with, you will end up with distributed like spaghetti code. Nobody knows what the event does, and your events will not be consumed. When you use Avro, you can also use the Avro schema registry. This doesn't mean that you need to come up with API guidelines yourself. There's a lot of examples out there. Many of these are very good. You can use this as a starting point and then maybe iterate over these. I have a lot of good information with those, experience with those from Zalando. I think some of my former colleagues in the room will have the same opinion of that. It's very nice, well-curated list of API guidelines. Now, there's one quote that I would like to share about creating APIs or creating API guidelines as Postel's law. This is also known as the Robustness Principle or as the tolerant reader pattern. Be conservative in what you do, be liberal in what you accept from others. So, as a consumer, if you don't need certain fields, don't go reading them. Just only use the information that you need, and then you will make sure that will allow you to have options regarding backwards compatibility. He actually came up with this when he wrote an early specification of the TCP spec. So it goes a long way, but it's still very valid. Guidelines alone obviously are not enough. You need documented APIs because your consumer might not be able to physically talk to your producing site. This is also valid for events like the Avro schema that I showed you earlier. So I kind of like the Avro events, but before this talk, I was actually trying to make sure that the legacy application was running Spring Boot 1.5 and the new microservice was running Spring Boot 2. When you use a serialized version of the event that you're passing, it's very important that you know if there are any technology constraints regarding your, in this case, Avro message converters. It's the same problem that we had a long time ago with GMS messages and with serialization in Java. If you don't explicitly, for example, define your serialization ID, and you just count on Java to generate that for you, then it's very likely that a new version of Java will create a new serialization ID, and it will be impossible to consume the messages that you're trying to post on your queue. I will look into that more into detail, and I will update my code when I figure out how to make that work. So there's a lot of possibilities to document the APIs. If you're using serialization in between, that's also something to take care of. Now, is it possible to actually do this without asking permission? Well, it depends. If it's possible to establish a culture of continuous experimentation, then you will be able to do a lot of innovation. This is something that a lot of very large organizations are doing. They're trying something small, they're making it bigger. If it works, they continue working on it. If it doesn't work, they just throw it away. There's a very interesting article shared at the end of the presentation on how continuous experimentation has led to a lot of software that we're using right now. I mean, most of you will know the story about how Google does this, how Google Maps started out and things like that. This is really a business opportunity that we're not actively grabbing. Microservices are small, they're loosely coupled, so they enable this kind of experimentation and innovation. And this actually brings another opportunity. So in the demo I showed, we said, okay, we're not going to use the calculation method from the legacy application. We're going to be using the microservice for that. But that doesn't mean that we need to do that for every possible user. Maybe we want to use something like traffic routing, where we route a part of our users to the old legacy application and other users to the new application, and maybe ask them how they feel about it. Does it work the same thing? Does it give the same results? Is it faster? Is it slower? And learn from these, learn from your experiments, so you can really use a data-driven process to make decisions. Distributed systems are hard. I'm not going to talk about the fallacies of distributed computing, but I think most of you know that networks are not very reliable, that transport is difficult. We need tracing, we need reliability, all those kind of things. If you're not asking for permission to do something, this is an extra challenge. But at the same time, it's also an opportunity. It's an opportunity to introduce logging, monitoring, distributed tracing, so technical components that add value to the application that you're building. If you have a product owner that doesn't see the value of this, then find some kind of large television and put your monitoring dashboards on that he can see the state of the application while it's running. So it doesn't need to ask a question, is the application doing fine? Do we have many users? You can just see that at all times. That's really a business opportunity. Maintenance. When Tony Stark had one Iron Man suit built in the cave somewhere in the desert, he had the one Iron Man suit. After a while, he had multiple Iron Man suits, and he needs to maintain all of those. It's no longer enough to know one technology stack. You will need multiple. You need to think about bug fixing, about extensions, about upgrades. Because you can use new technology for microservices does not necessarily mean that you should always pick something new. It's very useful to do some kind of technology selection. Say, okay, this is the stack that we're investigating. We want to be aware of what this does, and we want to learn more about this. So it's not technology for technology's sake, but there needs to be a business purpose as well. It's easy to be very how should I put it, to be very ironic about DevOps, but when you get the opportunity to select technology, then you should also be taking ownership for it. You were allowed to do something, you need to own up to it as well. If you do it in that manner, then selecting new technology will often not be a showstopper, and they're not going to say, no, you need to use Java 6 because our old WebLogic server uses Java 6 and everything is happy and everything works. So if you say, no, I will own to it, our team will be ready for using maybe Java 9 or 10. So again, this is also an opportunity, because if you have a monolithic application with a huge code base, then introducing new versions of libraries, of new versions of the language will be very difficult. Everybody has gone through Hibernate upgrades and was left crying at the end of the day. I know I have. So it's easy if you don't need to be constantly aware of this. Middleware runs on my machine. This is not. It can kind of be an issue if you're creating something in Java and you have a new JVM. Then that JVM needs to run somewhere. It's no longer easy to just pick up the war and deploy it to your application server. You will have multiple wars. Probably you will have a lot of runtime dependency on each other. This actually was a selling point of enterprise application servers in the past. It was everything. It was an HTTP server. It did queuing, it did JMS, it did load balancing, it did monitoring, it did everything. And there's a good reason why these have fallen out of grace, because it's very difficult to do everything right. If you have access to cloud services, if you're allowed to do that, then this will become a lot easier. So maybe that's also something that you want to fight for. If you use it as an experiment and you learn from it, you can also use that information to start convincing other people of the benefits, why you can do things faster with better technology, with better tools, and be a happier developer in the long run. As promised, a list of all the a couple of links that I've used. I really recommend watching Greg Young's talk. The quality of the recording is actually not that good. But it's still one of the best talks on DDD out there and on DDD Lite, in my opinion. I will update my GitHub link when I figure out the Avro thing. And that's it for my talk. We still have 6 minutes for questions, so I can't see anything, so just shout very loud.
raise your hand, please, and I will go with the mic.
So you had a slide in the beginning with multiple databases and message queues, and you also mentioned that you work in the banking domain. And if you work in the banking domain, then you know how important ACID, you know the acronym, right, is for banking.
Yes.
So how do you, can you explain that a bit? You know, these contradicting forces.
That's an excellent question. What we do right now, and that's I think one of the first steps, is we are using the asynchronous events for non-banking related transactions. So the bank I work for is very proud of the way that they're handling calls to their mainframe. It is possible to update it from their mobile application and it will be instant. There's not a lot of banks that are able to do that, and they're not giving that update. They don't want to even discuss that. So it needs to be instant, it needs to be ACID. But there's a lot of things around that goes around in banking and financial institutions that are not directly related to monetary changes. And there you can bring a lot of opportunities. I'll give an example. We integrate, so the system that we're building integrates with a lot of external parties. And we pat ourselves on the back saying, okay, we will be more reliable than all of them. I mean, that's what we're there, that's what we're trying to achieve. So when some of the external systems goes down, we will send the events again when they are back up. This is a value that you can show to your customers, saying, okay, even though the HR system was down for a couple of hours or for a couple of minutes, no data has been lost. If you use ACID, if you do a synchronous transaction to a database, then that's something that also needs to be cached somewhere and then need to be retried. And when you do this with events, you basically get it for free. But as I said, the banking transactions is not something that's being done asynchronously, and I don't think that I doubt that they ever will.
Thank you.
You're welcome. You're also working in banking? I assumed so.
So the question regarding monolith and one common database, there is one kind of benefit you get to access all the data you need for every small function. When you transfer to microservice, you have to think in advance about all the data that this microservice will need to do the functionality. And on one hand, you have isolated functionality. On the other hand, you have a lot of data kind of duplication. If there are dependent domains, then what's the strategy? How you decide how much to move or to provide some service that the other microservice can query to get some details it needs, or
okay,
what to do with this?
So in general, my suggestion would be data duplication in itself is not a bad thing. All the Oracle people are going, no! It's important that you know what your master data is. If you're the service that's publishing the events, that will probably be the master of that specific data model, and then you need to guard that data model, but maybe other parties are interested in that as well. So it goes even further. You can even start publishing data without having consumers already available. If you have this kind of ecosystem where as a producer of data, you put this data in your events, and maybe later other will be able to use your data, and your data will actually become more valuable because it's not being used by just one application. So yes, I think it's important that you state what your master data is, and when you publish an event, that data stays over there. And that's also why there's three kinds of data. There's the data that the publishing service owns, and it keeps on owning it. That doesn't change. It's still the owner of that data, but you can also add new information. So like in the Java implementation, you saw the map, and it can be useful to put not all the master data in there. You can just put some data in there that might be interested to consumers, and then also add other data so that you don't need to query those immediately.
But don't we then move from one central database to one central event bus?
Yes, please. Yes.
Then we just change database for event bus, and basically
If you, it kind of depends on your eventing system. If you use something like RabbitMQ, the messages are not persisted, so when they're consumed, they're gone. If you use something like Kafka, there will be a persistent store behind, and you can use things like event sourcing, where you use your events to replay whatever has happened in the past. So there will be some kind of master of your data. That will always be the case. It just depends on how you want to use this data between all the interested parties in your system.